In today's video, I'm going to go through another solution to a Stanford Uni exam question. So in this problem, we're asked to find the distance of P from the fourth corner given the dimensions there. And the solution is going to use a particular theorem called the British flag theorem. Now this is a theorem that actually isn't taught in school, but is an interesting result that we get just from considering a point contained inside the interior of a rectangle. So the theorem says that if a point P is chosen inside some rectangle, then the sum of the squares from P to the two opposite corners of the rectangle is equal to the sum of the other two opposite corners. So in terms of the letters that I have been given here, the theorem states that AP squared plus PC squared, or CP squared, is equal to BP squared plus DP squared. And once we know that, it's very straightforward to find X, but I think it's interesting to see how do we actually arrive at this particular theorem. And so what we're going to do to start is we're going to add in two lines that are perpendicular going through P. And you'll see how this theorem gets its name. So I'm going to add in firstly a vertical line through P that touches the sides of the rectangle, and one horizontal line. So you can see, even though it's not completely symmetrical, it somewhat resembles the British flag. So let's give those other points a letter. So let's call this Y, call this X, W, and Z. All right, so in essence, what we've created here is a series of right angle triangles. So we can see here that I have a right angle triangle there, here, and we've got one over here, and also down below there. So what I'm going to do is I'm going to basically just use Pythagoras' theorem to work out a relationship between the sides, and then hopefully I can see that some other sides are the same as others, and see if I can simplify it down in order to arrive at this particular result that I have written here. So to start with, let's consider the bottom triangle. Let's consider triangle DPW. So using Pythagoras' theorem, we'll have that dP squared is equal to dW squared plus PW squared. Now what I'm going to do is, instead of using PW, I can say that PW is the same as ZD. So I'm going to actually replace the PW squared with ZD squared. So we can actually write this as DW squared plus ZD squared. And I'm going to basically do that for all four triangles. So now I'm going to actually look at the triangle AZP. So that means we have that AP squared is equal to, instead of using ZP, I'm going to use DW plus, and then I have AZ or ZA squared. Okay, moving over to the right, and I have triangle, so we're looking at triangle BPX. So we can say that BP squared is equal to WC squared plus ZA squared. So can you see how I'm picking and choosing where I'm swapping my sides? So I'm trying to actually ensure that I'm using the sides that I've used in my previous theorems, because that way I can actually eliminate some and get the relationship above. And the last one we can have is CP squared is equal to, again, I'm using what I had in previous one, WC squared plus, and I can use ZD squared. So ZD squared will be the same as WP or XC. Okay, so I've deliberately chosen, so it wasn't just a random choice of sides. I'm choosing them such that I can eliminate or choose ones that I've already used before. So now what I want to do is I'm going to add each of those opposite lines going from P. So if we take dP squared plus BP squared, okay, so that's the two opposite, going to the two opposite corners. That is going to be, okay, so directly just taking what we have above, dW squared plus ZD squared plus WC squared plus ZA squared. Okay, so we can see that this is actually the same as dW squared plus ZA squared plus WC squared plus ZD, just moving around the addition. And we can see here that dW squared plus ZA squared is what we had for AP squared. And we can also see that WC squared plus ZD squared is what we had for CP squared. So let's go ahead and substitute those. So this is AP squared plus CP squared. And there you go. So therefore, we have our original theorem that we started with. Okay, that the sum of the squares of the two opposite sides going from P are equal. Okay, and it's called the British flag theorem. All right, so now all we have left to do is substitute our numbers in and we can solve that simple equation for x. So we're going to have 10 squared plus x squared is equal to 5 squared plus 14 squared. Okay, so this is one equation with one unknown, so we can just simply solve this by bringing the x by itself. So we're going to have 25 plus, now we can have, bring the 100 over, and we're also going to have 14 squared take away 100. So x squared, so what's that going to leave us with? 121. All right, so obviously x, when we take the square root of both sides, okay, but we will only consider for positive x, and we will get 11 meters. Okay, so the distance of x is 11 meters. All right, so I always find it interesting when we can discover new theorems that we're not necessarily taught in school, but they do exist and do help us in these particular situations. So hope you enjoyed that one, and I'll see you in the next video.